Hello and welcome to another Solana tutorial. Today we're gonna talk about CPIs. Specifically, we're gonna go through the Solana development course, module 4, part 3. Cross-program invocations. Yes. That's an interesting topic that we have not yet discussed in detail. Cross-program invocations essentially are a program calling another program. So like you build a transaction to call an instruction on a program, that program can then also build a transaction and call that program, except it doesn't create another transaction. It's all done in the same transaction. It just calls that other program. So we in our transaction already need to be aware of that other program, because we obviously need to provide the account for it or the accounts for it. But essentially, CPIs are just programs calling other programs. And there's some details to that we're gonna have a look at today. So let me go down here and let's get started with cross-program invocations. Let's go. What are we gonna learn today, James? We're gonna learn what CPIs are. Okay, we're gonna describe how to construct and use CPIs. So that's programming the program that then does stuff. And we're gonna explain how a program provides a signature for a PDA. That's interesting. We talked a lot about PDAs in previous lessons, but we didn't actually sign for another account yet. I mean, that's one of the main use cases for PDAs. That was the special thing about PDAs. Since they belong to the program can sign for that particular address as if it had the private key for it. Which means when we call another program via CPI, we can add an additional signature, right? Because obviously if our program is called, then it doesn't have the signature for that particular address yet if it's our PDA, since only we as the program can create that signature. And that signature only really is created when we call another program, because then we can tell the other program, yes, it was us calling you. Because otherwise it doesn't make sense, right? If we stay in our program, we don't need to provide the signature because we know we are ourselves, right? We don't need to sign for the PDA. If I know it's my PDA, I'm like, okay, cool. But if I call another program, I can tell that program, yes, it was me calling you. I own this PDA, or I have the authority of this PDA. I can sign for it. Now, me being the program, the my program. Is this confusing? Well, maybe. But let's continue. We avoid common pitfalls and troubleshoot common errors associated with CPI. So that's always cool, because people always have issues, not excluding myself, especially including myself. I have a lot of issues. But I also have issues with CPIs sometimes. So yeah, let's learn about that and not the rest of my issues. So the TLDR is a cross-program invocation is a call from one program to another, targeting a specific instruction on the program that we call. Yeah, cool. CPIs are made using commands invoke or invoke signed. Yes, that's how we call them. Invoke signed, the difference is just that we provide a signature for one of our PDAs. Yeah, that stands here. Perfect. I'm so smart. CPIs make programs in the Solana ecosystem completely interoperable, because all public instructions of a program can be invoked by another program via CPI. Wow, how cool. Hashtag composability. That's what they were talking about, right? Yeah, basics. Amazing. Okay, so let's jump right in, because I don't want this video to be 2 hours long again. What the hell is a CPI? A cross-program invocation, because I haven't said that enough, is a direct call from one program to another. Okay, so maybe think of it as an additional instruction, because that's what it is, right? When we do a CPI, it's just executing another instruction from another program. That instruction is not specified in the transaction that is sent from client side, but the instruction is specified within our program. And then the instruction is executed within our program. If the instruction fails, then obviously our entire transaction will fail. But if the instruction from the CPI comes back with success, we continue our program flow. You can make CPIs to native programs, other programs you've created, and third-party programs. Yes, so essentially any program that is available on Solana, you can call it because it's all public. You might not know how to call it properly, but you can call it. CPIs essentially turn the entire Solana ecosystem into a giant API that is at your disposal as a developer. Wow, that's a sales pitch, James. I love it. I love it. CPIs have a similar makeup to instructions that you use on the client side. There are some intricacies, a word I don't know, especially of an involved or perplexing subject. Intricate. Definitely heard it before, but like whatever. So there are some like details and differences depending on if you're using invoke or invoke signed, and we'll cover both of that later. Okay, well, why are we even talking about that then here? Let's talk about it later, okay, James? How to make a CPI. Now, we are inside Rust, native Rust, not Anchor yet, and we want to call another program. There are set two functions, invoke and invoke signed. Great at the marking part today. CPIs are made using invoke or invoke signed. So essentially we always invoke another program. Those two methods are both in the Solana program crate, and when you invoke, you essentially pass through the original transaction signatures that we already received as the program. So for instance, if the user signed and then from his wallet I want to send some SOL to wherever, then I just invoke because the signature of the user is already there, and then the system program will check the signature of the user. That's fine. And you use invoke signed if I want to sign as my program for a PDA. So that I would do if I call the system program to transfer some lamperts out of my PDA. Then I need to sign for it because that signature is not yet already present at the signatures in the transaction. So without additional signatures, the instruction that we want to call, so we have to build the instruction, like for instance, the system program transfer instruction, and then the list of accounts that we need to provide for the instruction. Remember, each instruction, because each program has one entry point and it just reads the accounts, we provide those accounts here. And they can be a subset of all the accounts provided in the transaction, which also means that we can only use accounts that were specified on client side when building the transaction. That's why we also need to know what the other program is doing, because we need to provide the accounts, obviously. Same as if we just call a program from client side, we also need to know the accounts. Now we just need to go one level deeper. All of the accounts being used in all the levels. Right. And if we also want to provide a signature for a PDA, there's an additional argument, signer seeds. And this one is interesting because it's a reference array of reference array of reference array U8. So, no, let me say that differently. It's a slice of a slice of a slice of U8s. And if that might seem a bit confusing, it's because it is. It took me a long time to understand this as well, but I do understand it by now, and I can explain it to you. Wait, but didn't I already make a video about all this stuff? Maybe it was not within the development course, but I definitely made a video. Check that out. Oh, I don't have such a long hand. I'm sorry. My hand ends here. I need to point, and I also lose my elbow. Anyway, the innermost slice of U8s, that's just, you know, a bunch of bytes, right? So that could be a public key, a static list of bytes like B and then string, whatever. That's one element. But as we know, the seeds can have several of those slices. So that's where this comes in. So we can provide just a static string plus a public key plus another public key that contains my seeds. Oh yeah, and then at the end plus my bump. At the very end, we also need the bump, which is just another slice of U8, just containing one byte. So this slice makes up all of those. And then since we can sign for several PDAs, like if we have one PDA and another one, and we want to sign for both of them, then we can have yet another layer of this, right? So put another brackets around, first the first seeds, then the second seeds. So That's why we have a slice of a slice of a slice of U8s. I hope that makes sense now. And by the way, you don't need to provide the seeds in a particular order. Solana is smart enough to take those seeds and then derive the address from it. And if that address is within this list of accounts, then it adds a signature to it. Then it says this one is a signer, right? That's how this works. So you don't need to specify for which PDA you're creating the seeds here, or you're providing the seeds here. That will work automatically, at least as far as I know. And then what's coming back is a program result. So we already know this. It's okay or error. And the error can have a error code and whatnot. CPIs extend the privileges of the caller to the callee, meaning that all the signatures provided to me, to my program, will be available for the program that I call. So you need to be aware of that, right? If the user has signed and you call another program, then it's as if the user calls the other program and signs this. So obviously comes with some risks if you're not aware of that. But and as far as I know, you can't really remove a signature. But if that would be relevant, then you're probably doing something wrong anyway in your layout. But anyway, so both the signer and the writable flags will be passed to the program that we call. So all of the accounts that were writable will also be writable when we inside the instruction that is executed. It's important to note that you as a developer decide which account you pass into the CPI. Yeah, you can just not provide some of the accounts, obviously. So just think of CPIs as building another instruction from scratch with only information that has been passed into your program. As I said, we already need to have the accounts. Otherwise, we can't pass them in, right? Because we can't invent accounts. They need to be determined beforehand. That's C-level requires that. So that the runtime requires that. Let's go. CPI with invoke. Let's invoke something. As we had it before, we need an instruction and account infos. And if we have a look at that again, basically first lesson, an instruction contains the program ID, the accounts, and the optional instruction data. So this is a bunch of bytes. This is account infos, and the program ID obviously is just the public key of the program that we want to call. And then now this is where it gets confusing, because here we have the account infos again. So this is the account info that we need to provide that the instruction then reads. So let's see what the difference here is. So that's the public key of the program we invoke. Yeah, that's obvious. List of account metadata as a vector. You need to include every account that the invoked program will read or write to. Yes, obviously. And then a byte buffer as a vector. Yes. Account meta, accounts field, expect a vector type of account meta. The account meta struct has the following definition. Oh, there we have it. Cool. So there we just need to sign which account is it, and is it a signer, and is it writable? Because later we will set some to true here that were not true yet when it's our PDAs and we want to sign for them. But apparently I could just set them to writable false if I don't want the sub program to be able to write to them. That should also work because I provide it here in the account method. But obviously the other way around doesn't work. If it's not writable for me, then I can't suddenly make it writable. Yeah, and then the account info, does James talk about that as well? And then the account infos, we require a list of account info objects, and those we can just copy from what we received in our instruction, and we copy them by using the clone trait. Clone trait returns a copy of the account info instance, such that we don't get issues with lifetimes and stuff. Depending on which program we call, there might be helper functions that make it easier for us to create those instructions. Like if we do a system program transfer, that's so common that there is a separate function to create that instruction. Or a lot of stuff with SPL token, for instance, there's also helper functions to create those instructions, such that we don't need to manually provide all of those things, but we can just call the SPL token transfer, for instance. In this lesson, we'll be using SPL token create to create minting instructions. Okay, right. So we've talked about the accounts, and then we just provide them as a vector. Oh, by the way, if you don't know what a vector is, that's similar to the buffer that we had in TypeScript, or an array, or a list. It's something like that. bit more specific though. Essentially, we don't need to provide the size. So it's more like a slice than an array. But a slice is a part of an array. So it's a bit complicated with those types. But a vector we can create like this with a vector macro and then providing the data in square brackets and reading the data by, as you would with a normal array or slice, access that. And yeah, we build the vector of accounts like this, and then also the vector of data, because that also is a vector. This time the type though is U8, so the data inside the vector all must be U8s. So that's essentially what we know as a buffer in TypeScript, right? We have a bunch of bytes. Here we put them in a vector. Should we really find out what the difference between vector, array, and list and all of that is? My take would be array, the length is known at compile time. List, the length is never known, like it's always dynamic. And vector is, it's not known at compile time. So when you create a vector, you need to provide the length, but that is not known at compile time. That would be my take. So arrays, vector, slices. Rust has list types to represent a sequence of things. The most basic is the array. Fixed size, same type, immutable. A vector is a dynamic or growable array. Vectors always allocate their data on the heap. Vectors are to slices what string is to str. But do you know that difference? Not really. You can create them with the vec macro. Okay, so the vector is also dynamic. We can also push more into it, which means essentially the vector is a list, but internally might still be different because it's not like the linked list, but more like an array type. But that anyway, let's not go too far into detail. So we now hopefully know what a vector is. Think of it as a list or like a growable array with capacity 3, and then we push 1, 2, and then we extend from slice to LE bytes. So this is a slice that we put in a number 2 little endian bytes, and then we then also add. But then I don't really get why you put 3 here, and then you push 2, and then you anyway. I mean, because I think this number, depending on what number thing it is, if that's just a byte, then okay. But if that's a larger number like a U33, in which case it would make sense to convert it to LE bytes and not just pass it in like that, but then it would be more bytes. Anyway, let's not overanalyze this. The extend from slice is a method on vectors that takes a slice as input, iterates over the slice, clones each element, and appends it to the vector. Yeah, so we can provide a slice here, and then it will copy over the elements from the slice into my vector. That's the extend from slice, in case you ever need that or read that and want to understand what it does. Cool, so that's then the program data that we can supply like this with the vector of bytes. And then we have everything, program ID, the accounts, and the data. So let's continue with CPI invoke. With both the instructions and the list of accounts, you can perform the invoke. So that list of accounts, so that's not the meta, that's the account info now. Remember, the account metadata was this that we put in the instruction, and then we also need to provide all of the accounts, the account infos in here. Yes, I know, a bit complicated, but you just need to get used to that. We do that by essentially cloning our account infos that we already have in the program. And once we have all that, we can now do the CPI with invoke by, essentially this thing. And notice the question mark in the end, which means that the program result is already unpacked, and if it's an error, then the error is raised, and if it's not an error, then we continue. That's what the question mark does here. So in case this instruction returns me an error, so not success, then that error will be raised to our program result within our program, and if success comes back, then we just continue. There's no need to include a signature because Solana runtime passes along original signatures. Yeah, that of course won't work if you want to sign for a PDA. So if you require a signature for your PDA, then we need to use invoke signed. So let's have a look at invoked signed. Essentially same thing, except we have another slice of U8s for the seeds. So it's a little different because there's an additional field for the seeds used to derive the PDA, which we need to provide again to sign that transaction. instruction, really, instruction. You may recall from previous lessons that a PDA does not lie on the curve, yes, and therefore has no private key, yes, okay. And you've been told that programs can provide signatures for their PDAs, but you have not yet learned how that actually happens until now, or my previous videos. So we provide the signature with the invoke sign function, and the first two fields are the same as with the invoke, but we have an additional signer seeds that comes into play here. Bam! So that would just provide the seeds for the first address, the seeds for the second address. And you can already see here, he splits it. So the uppermost, so this one is the first address seed. It only has this one static seed here. And the second seed here, so the seed for the second address, that consists of two of those seeds, like second address first seed and second address second seed. So that's why we have two of them here. And that's why we need those triple slice. This thing itself here is a byte slice. So this is a reference of U8s. It's just now represented with the string, but it's a reference of U8. So I have reference, so I have slice of U8s. Cool. So to reiterate, PDAs have no private keys, but can be used in an instruction that includes the PDA as a signer. Of course, only if it's a PDA of our program. And the only way that the runtime can verify that this PDA belongs to us, so the calling program, it's by supplying the seeds used to generate the address. So by providing those seeds here, we say to the runtime, hey, look, I know the seeds for this PDA, hence it's my PDA. Well, there's one more step. I know the seeds for this PDA with my program ID, obviously. And then runtime can check, well, PDA with your program ID and this seeds, oh, it actually results in that address, which means it must be your PDA. So I allow adding the signer field for this account. And the runtime will internally call the create program address with my program ID and this list of seeds, and then it will compare the result against the addresses supplied in the instruction. And if we have a match, then the runtime can say, yes, we allow this to be a signer, right? So one of those counts, the signer field will be set to true, or we have to set it to true, but the runtime allows it. A little more theory first, a little more. So best practices and common pitfalls. Security checks. Yes, because security is important when we program Solana programs, since we always deal with some kind of value. And we don't want to be hacked and stuff. And there are some common mistakes and things to remember when utilizing CPIs. First thing to remember, we have no control over what information is passed to our programs. Yes, as we already discussed in like a security lesson. Did we do that? Yes, we did one, right? Our program is public. Anybody can call it with any kinds of parameters. All of the instruction data and all of the accounts can be whatever the user pleases to put in there. So we in the program need to make checks that those things are actually the things that we would expect. And that includes the program given to us for the program that we call. Because obviously that needs to be an account that is provided from the client side, so within the transaction already. And we could just take any program ID and call a CPI on it. However, that's not very secure because then we call any program that the user wants us to call with the signatures that we have, and maybe worse, even additional signatures from our PDAs. So we really need to check which program do we call, or even better, hard code the program ID into our program. Like if we want to call the token program, then hard code that token program ID in there. Even though now that there are several token programs and they are passed in, yes, but then at least check that it's one of the allowed token programs. And yes, having several token programs makes all of this very complicated, but that's just life. That's just the life that we live and the sacrifices that we need to make for composability. Anyway, what was I? For this reason, it's important to always verify the program ID, accounts, and data passed into the CPI. Without this security checks, someone could submit a transaction that involves an instruction on a completely different program than was expected, which is not ideal. Yes, that's what I just talked about in my very emotional speech. Fortunately, there are inherent checks on the validity of any PDA that are marked as signers. Yes, so obviously, if another account is provided than the PDA that we provide the seeds for, then obviously the signature won't match. But you still need to be careful because maybe you're signing for 2 PDAs, and better always check what accounts you're passing into the CPI. If you mark them as signers and they haven't been signers before, then you can be pretty sure that the right one is passed in because they will be checked anyway. If you then don't provide the right signature, then an error will happen, like signer privilege escalated. So you're safe on that front. You don't need to derive the PDA again just to check if it's the right address, because that happens anyway, as we said, with the create program address. That's done by the runtime anyway if I provide the seeds. But the rest of the accounts and the instruction data you should double check. Should also make sure that you're calling the right instruction on the target program. The easiest way is to read the source code. Well, yes, James. So easy. Because that also never changes, because all of the programs are immutable. Right. All of the programs should be immutable. They're not, though, unfortunately. Also, programs can change. Be aware of that. That's another security implication, right? Even if the program ID stays the same, somebody has the update authority, or like if somebody steals the update authority and deploys the program again and suddenly the program does something completely different, you can also end up being exploited. But like, just be aware of those things. Usually the safest way is to use the APIs or like libraries provided by them, because they make sure that the right program is called the right form. But anyway, otherwise it will break and transactions will just fail, which is not too bad, right? All right, let's go through some common errors such that you have seen them, such that you know what they mean if you ever encounter them, which you probably will if you're doing anything with Solana programs. So there are some common errors you might receive when executing a CPI. They usually mean you're constructing the CPI with incorrect information. For example, you may come across this message, blah, 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 any public key, signer privilege escalated. Cross-program invocation with unauthorized signer or writable account. So essentially that privilege escalated just means that you don't have the authority. You don't have the privilege. It's not a signer and you want it to be, is what that says. And that can happen if the seeds you are providing are incorrect, for instance, or not the right seeds for that particular account. So either the seeds are incorrect or the account is incorrect, right? It's just saying they don't match. Seeds and account don't match. When it derived the public key for the given seeds with the program ID, then it did not find that account that you provided and said should be a signer. Another similar error is thrown when the account that's written to isn't marked as writable. Then we have writable privilege escalated, and the same program error. This is not specific to CPIs. That can also happen in a normal transaction. Well, actually, then you wouldn't get that error message because we're not having a cross-program invocation. But anyway, writer's privilege escalated just means that the account wasn't marked as writable, or so mutable, but the account data was changed, or any of the account fields. Could also just be the Lamperts. So basically, the account was written to, but we didn't specify that account as writable. We didn't specify that that account should be written to, or can be written to. Any account whose Lampert's balance may be mutated by a program during exit must be specified as writable. Mutating the Lamperts of an account that was not specified as writable will cause the transaction to fail. While subtracting Lamperts from an account not owned by the program will cause the transaction to fail. Adding Lamperts to any account is allowed, as long as it is mutable. Yes, that might also sound very confusing. It basically just means anybody can send me some sol, so top up my Lampert balance, but only I, so if that is my account, can I subtract Lamperts from this account. And the word here is owned, so the account must be owned by the program, and then that program can subtract Lamperts. The default accounts, like wallet accounts, they're owned by the system program, and therefore we need to provide a signature to the system program such that the system program can do the transfer. So what we do is we create an instruction to the system program, a transfer instruction, and we add the signature for our wallet, and then the system program transfers those Lamperts, because the system program can subtract Lamperts and also add them to any account. Yeah, that's just also some good to know stuff. You can just add Lamperts to any account, but for subtracting, you need to own the account. And if you still want to subtract, you can just do but you don't own the account, then you can just do a system program transfer instruction using a CPI. Easy. However, you will need to provide the signature such that the system program will allow you to actually move them out. Yeah. Anyway, so last bit of theory. Why the hell do CPIs even matter? CPIs are a very important feature on the Solana ecosystem, and they make all programs deployed interoperable with each other. With CPIs, there is no need to reinvent the wheel when it comes to development. Yes, so everybody can use the token program. Also, programs can use the token program using CPIs. Not every person doing anything with tokens needs to deploy their own program for it, as is the case on some other blockchains. No hate. This also comes with its own issues, right? So it's not all great. He says, knowing there will be like 20 token programs, or at least there are 2 now. This creates the opportunity for building new protocols applications on top of what was already built, just like building blocks or Lego bricks. Yes, Lego bricks. Thank you, James. That's a great analogy. It's important to remember that CPIs are a two-way street. And the same is true for any programs that you deploy. If you build something cool or useful, developers have the ability to build on top of what you have done. Yes, so anybody can then do a CPI and use your program, which can be cool or also annoying at parts. Composability is a big part of what makes crypto so unique, and CPIs are what makes it possible on Solana. Yeah, sales pitch again. Now, if we have one program being called and that does a CPI, and that again can do a CPI, and that again could do a CPI, so like my program calls the token program, which, I don't know, creates a new mint, which requires the system program to create the mint account. So we have already a 3-step thing here. So the depth here is 3. There is a limit to how far we can go, how deep we can go with CPIs. I don't know it by heart. Was it like 5, 6? Solana CPI depth. Calling between programs, Solana docs. Well, that looks good. Call depth. But the depth is constrained currently to 4. Okay, so there is only a maximum of 4. Not sure if they're counting the first program as well. So if it starts at depth 0 and then I can do like 4 more. So we have 5 programs, or if that's already counted, not sure. But yes, I think it was 5. Okay, good to know. I definitely wanted to put that into this lesson as well, because that's a relevant part. You need to know that there is a maximum depth for CPIs, and it's currently 4. So I think it's 5. We could try, and I'm hoping that that gets extended, because some programs already reach the limits. Because it's way too easy to reach the limit, right? System program, like, you often need that, and the token program uses that, and so our program uses those 2, and then we might be like a DeFi thing, and then there might be an aggregator program, and we are already at level 3, and then there can only be one more program and we have the full depth, and then it's like over. So yeah, might get extended, might not. Currently max depth is 4. What else? Another important aspect of CPIs is that they allow programs to sign for their PDAs. Well, I think we have discussed this. As you've probably noticed by now, PDAs are used very frequently in Solana development. Yes, because they're so useful, damn it. Also, I keep making videos about them. This can be very useful, damn it, for many applications in Web3. Without CPIs, PDAs would not be nearly as useful, because useful, damn it! Because there would be no way for a program to sign transactions involving them, essentially turning them into black holes. Once something is sent to a PDA, there would be no way to get it back out without CPIs. Disagree, James. I disagree. Your program itself could get it out. If the program owns it, the program can change the lamperts. So as long as I own it, I can just remove them even without the CPI. If my program owns it, the account, and my program can change the lamperts also into negative. Like, not negative, but like subtracting is what I mean. Lamperts can't be negative. It's a U, so unsigned 64. So yeah, James, I disagree on this statement. Because the whole thing with the signatures is also just a thing. It doesn't really mean anything. It just shows that you own it. If a program doesn't do anything with a signature, then the signature is pointless, right? And I, as my program, I know it's my account, so I can do whatever with my accounts. So I don't require the signature, right? So I would argue PDAs are also very useful without CPIs. They are just even more useful with CPIs, because then I can also sign for other accounts. Like then I can also sign for my accounts and use them in other programs. Otherwise, I could just use them within my program, like in the signed version. Because I don't need the system program to remove lamparts of my accounts if I own them, I being a program. Moving on. Let's get to the demo. The movie review. Oh, we haven't worked with that in way too long. Let's do it. So in previous lessons, we allowed users to submit reviews and stored them in PDAs. We added the ability to leave comments. And now we're going to have the program mint tokens to the reviewer or commenter anytime a review or comment is submitted. Okay. So like a reward for participation kind of a thing. For this, we have to implement the SBL token program's mint to instruction using a CPI. If you need a refresher on tokens, check out this lesson or this video. Yes. Starter code and adding dependencies. This is always the hardest part. Getting it set up. Git clone. And then check out, what was the branch again? Solution add comments. Oh, switch to new branch. Anyway, I hope that's good now. I have to make it a bit bigger for you. I think that should be fine, right? Or bigger? No, it's even readable on the small screen, so it's fine. It's gonna be fine, yo. So, first thing we do after getting the starter code is adding dependencies to cargo toml. So I'm just gonna copy this. Hey, there's a button. How nice. In the cargo toml, we're gonna add in dependencies the SBL token and the SBL associated token account. Okay. Cargo check to see if you're ready to continue. REST analyzer is also still analyzing. Okay, this is gonna take a while. Let's see. Because we want users to be minted tokens upon creating a review, it makes sense to add minting logic inside the add movie review function. Since we'll be minting tokens, add movie review instruction requires a few new accounts. Token mint, mint authority, user ATA, and token program. You know what? I think I'm gonna speed run through this part and then only do the really interesting part, which is the CPI. Because, you know, adding accounts, I think you would manage, right? This is a draw after numbers. How do you say that in English? Copy paste stuff. Oh, process. So that's why we have all that thing. Add movie review. Oh, come on. Don't make me wait. Then I find it manually. Okay, can you just stop for a second? Failed to select version for SBL token. Oh no. Or did you have an equals? That's not good. You can use newer versions. Still a problem. Okay, how about SBL token create? The current version is 350. So we take 350. And this current version is there. 150. Oh, no, there's dependencies. 112. 112. So we can have, I would even go with this. Wait, I would even go with higher. 112. Okay, try that again. That's the current versions now. There we go. That looks better. Cool. While that's installing, we added some stuff to our processor. Mint tokens to the reviewer in add review. Let's input the addresses of the token program and the constant on top of the file. Okay, I mean, that I can do. Just adding some dependencies. Can do that. Initialize mint instruction. Get associated token address. We'll be adding this to the very end of the add, right before the OK. Minting tokens requires a signature by the mint authority. So, who is the mint authority, James? Since our program needs to be able to mint tokens, the mint authority needs to be an account that the program can sign for. Oh, so you're talking about the PDA. Okay. Nice. We'll also be structuring our token mint such that the mint account is a PDA account that we can derive deterministically. Yeah, I mean, that makes sense. I mean, come on. I mean, we can always verify that the token mint account passed into the program is the expected account. Our token mint. Oh, sorry. So that's the mint authority, and then the token mint. We also want a specific. So this token mint, essentially, that's the token ID. You can also say that can also be a PDA. So just when creating the token, when we call the create token instruction, we need to sign with our program as well. And once we created it, we can then always use this. That's the same way you can use a vanity address for your token. There you just provide the key pair, but we can do the same as our program. And we can also make the token mint a PDA, just so we can always confirm that it's the right account. That's actually quite smart. Let's go ahead and derive the token mint and authority address using find program address. So token mint and token auth. I'm just gonna copy stuff because that's still PDA stuff that we should totally already know. So we finished with some warnings, but I guess that's okay. I'm okay with warnings. So at the very end, here we're gonna mint stuff. We're deriving the mint PDA and the mint authority PDA. Find program address from token authority and token mint. So that's all the seeds that we provide. And then for signing, we also need to provide the bump. And for the authority PDA, we can throw it away. I want this. Anyway, moving on for now. We'll figure it out. Now we'll perform some security checks. Always remember to verify your account, kids. Grandma talking here. Or grandpa. Grandpa James tells you to verify your accounts. Okay, what do we do here? Essentially, we check that the token mint that was provided is actually the token mint that we expect from this PDA. Otherwise, it would be a different token and then it would also just not work, but might as well provide a proper error message. The PDA, we check that that corresponds to the right authority. Then the user ATA.key needs to be the associated token account. So the ATA for this mint and this initialize. We want to make sure that that's actually the ATA of that user. And then we want to make sure that the program we're calling is actually the token program ID, which we imported from SPL token up here. So we're using the legacy or the normal token program. Cool. Finally, we do the CPI with the mint2. So that part I think I'll try myself. The SPL token crate provides a mint2 helper function for creating the minting instruction. Oh, that makes it super easy. This is great because it means we don't have to manually build the entire instruction from scratch. Amazing. Chill. And here's the signature. Oh, amazing. We don't need to do anything complicated here. So public function mint2. And if I now turn my REST analyzer on again, hopefully it gives me help on how to build this. The mint2 we also have. Did we include that already? No. Loading. You done? Yes? No? Maybe? Ready. Yeah, we have unused imports, but like mint2. There we go. That's what we want. That's what we want. So we're just gonna, where was I? There. We can just use that here then. Mint2. Oh, perfect. It tells me everything I need. Token program ID, which is the token program ID. Which is, what is that? A pub key, amazing. Then mint pub key is the token mint key or mint PDA. I can use any of those because we already asserted that they're both the same. Let's use the mint PDA, why not? Then account pub key, so that's now my ATA, user ATA.key. I would assume it requests a reference to pub key, so reference to pub key. Next, we have the owner pub key, and owner really is the authority because the token program just, it's so old that they still called it owner, which really is just an authority. That was my mint auth PDA. Maybe go next line. Signer pub keys. So who's signing for this? The mint authority is signing for this. So again, mint authority PDA. You're the only one signing for this, yes. And then the amount. How many tokens? Well, I don't know. One. One token per review because I'm greedy or something. Or like if we have, let's say, a normal token with 9 decimals, let's do like 1, 2, 3, 1, 2, 3, 1, 2, 3. That it's one token with 9 decimals. And that's pretty much it. Yes, cool. this stuff returns me... Oh no, that already does the CPI. I don't even need to build the CPI. How boring is that? That thing already does the CPI because it returns a program result. No. It returns a result, which is the instruction. Okay. Whew, I was already thinking this is way too easy, but no, it's just right. So it returns the instruction or a program error. Okay, it's not a program result, it's just a result with instruction or program error, which means we can do the following. We say question mark here, so if it's an error, raise it, and if it's not an error, then let our mint instruction be this. Yeah, doesn't like program ID. Expected a reference, found a pub key. Well, then here you go, have a reference. What else? Same here, probably. Expected, probably a reference to this. No? Yes? Okay. Looking better. Cool. And I think that's then pretty much, that's the instruction part. Now we come to the interesting thing with the invoke signed. And there we provide the instruction, which is our mint instruction, reference to that. Then the account infos. So it is an account info slice. It doesn't look like a vector. Oh no, wait, the vector was within the instruction. Right, okay, sorry. Here it's the actual account infos. So which account infos do we need? We need a slice, and here we have I don't think I need to provide them in a particular order, do I? Let's just try. I need the mint PDA. Wait, no. They need to be account infos. So that's the things we got from all the way up here. There was already an invoke sign. Cool. We already did that with the system program. Anyway, that's why we did that probably already. So those are the account infos that I need. So we have the token mint, mint authority, and user ATA. Oh, and token program, of course. Those 4. Token mint, mint authority, user ATA, token program. Token mint clone, mint authority clone, user ATA clone, and token program clone. There we go. Cloned them all. So let's put that in several lines here, such that you see it's the mint instruction, the account infos, and then the signer seeds. Well, there we just provide, it's just one PDA. So inside this we provide another thing, and inside here we provide the seeds for the PDA, which is just this thing. Oh, it is the token mint, the token authority. That thing needs to sign. The other one needs to sign when we create the token. And what we also must not forget down here is the bump. So in my eyes, for this thing, I would need this mint authority bump. I don't need the mint bump. I need the mint authority bump. Would be like, that's how I would do it. So I'm just going to do it like that until we find out what I'm doing wrong. Cool. So there we have my slice of. There we go. Like this and this. I think something like that. No, yes, no. Let's see if that compiles. And then we're done here. And we just again do question mark, because the invoke signed returns us. This returns us a program result. So if it returns a program error, then we just raise it. Otherwise, we get the result back, and the result will be okay. So we just ignore it, and then we say ourselves okay. Cool, that should be it really, but something is very red here. We expected this, and we found result of this, but that's why I put the question mark here. No, let's remove that for a second. Okay, there it does not seem to complain, so I'm probably doing something wrong with adding the bump. I want another bump. If I just provide the bump, but that's just one U8. But I guess that would also be okay. Oh, that already looks better. No. Yeah, that's what I'm saying. You're expecting a slice of U8, but I'm giving you just a U8. So this would be a slice of, this would be a reference of U8. Now you're still complaining probably. Yes, now I found a reference of U8, but you expected a reference of it. That's why I'm doing this. Now looking good, not complaining anymore. Oh, now it's good. I thought that was the same thing that I had before. Maybe not. Maybe I made a mistake with the brackets somewhere. Okay, cool. But it looks good now. I can go back in the video and then see what I did wrong, but like, looks good now. And we return on error and we just okay if not. Cool. And I think I'm done, except I neither have the token nor the front end to actually do stuff with it, nor do I have all those errors. So I guess I need to add them errors. But what would be the next step? Or first, let's check how we did. Minting 10 tokens to user associated token accounts. 10 tokens, okay. Oh, you're using Lamperts per sol? But it's not Lamperts per sol, it's decimals. It's like, it's a bit different. Using Lamperts per sol here only works if your token has 9 decimals, which on default it has. But still, that code looks a bit sketchy to me. I prefer my 9 goddamn zeros. And like the nicer way to write this would actually be like this. That would be an even nicer way to write this. On the other hand, the really nicest way to, or the nicest way would be this. And then it would be like 10 tokens. There you go. 10 times decimals. That to me looks better. And yes, now we have a variable here. This should be a constant, but come on. Don't be so picky, damn it. I'm never gonna actually use this. Yes, so how else did we do though? So we have the SBL token instruction mint2. Oh, he just references the entire thing here. I imported it, okay. Then he has the token program key. Token program, I mean, I used the other one, but that's fine. Token mint key, well, I used this one, but I guess it's fine. User ATA key, well, that I have the same. Hold on, but I'm not using references. Wait, no, he's not using references. I am. I guess. As long as my compiler doesn't complain, I'm gonna do it like that. Because I think if I remove that reference here, it's gonna complain again. It might later though, if I want to use those again. No, I feel comfortable using references here. So I'm going to give you a reference, yo. Because maybe I want to use this again later. I'm not going to give you the whole thing. Because otherwise I might get issues here or whatever. Anyway. And then token mint, user ATA and mint authority clone. So he does not provide... Oh, yes. Because if we call the token program doesn't need to have the token program as an account info. Right. So I can remove this part here. That was my bad. Thank you, James, for letting me know that I do not need this. And then how does it do it? Yes, like me with this, B, token mint, and then this. I think that's the same as I wrote here. Yes. Looks good. Then also with the question mark and okay. Cool. I'm also gonna add your message, because why not? Let's go and put that in this line so it's nicer. Yeah, there we go. Then we just need to fix those errors up here, and I think then we're fine. So incorrect account error. What did we call it? Incorrect account error. Give me the right account, please. This is a very nice message, yo. But we're using it for so many things. We're using it for the incorrect token mint, incorrect token program. I'm just saying, hey, give me the right account. And check the message above, yo. It's just so this is not read anymore. Okay, cool. Good. Should we try and compile this for a second? How did that go again? Cargo build BPF, right? No, SBF. Oh man, now you're downloading all that stuff again. Note that we're using invoke signed and not invoke. Well, yes, because we want to provide a signature for the PDA. Oh, actually, wait. You use the token mint? Explain to me why you're signing with the token mint here. You're minting 2 and you sign with the mint. James, explain. Explain. Like those things in Doctor Who. I don't even know what they're called. And it's been like 10 years since I watched that last. But like, anyway, getting off track here. Why with the mint bump and the token mint? I use the token authority and the mint authority. Is it just a wording thing that you're calling this the token minted, although it's actually the token authority? But no, you're using the token mint here as well, but that's just the account. Are you just confusing me? You're providing both of them as accounts, so that's fine. So yeah, before we repeat that for the add comment, which is going to be the exact same, I'll let you do that as homework. Adding the accounts and deriving the authorities, doing the checks, and then constructing that mint2 instruction and calling the invoke signed. I'll let you do that. I'm not caring about the comments now. I care about setting up the token mint because that is relevant. We've written all the code needed to mint, but all of this assumes that there is a token mint at the PDA derived with token mint. Yes, at the PDA derived with token mint. So not here. Like, that's just the token. Do you set the token mint as the mint authority as well? I mean, you could do that theoretically, thinking about it, because I still own that. So I could do that. Then I don't need two different accounts for that. Then you don't need the separate token authority, which is actually a nice thing now thinking about it, because we need to provide one less account. But still, I don't get why I hear you signing with the token mint. This still does not make sense in my head. Anyway, continuing. For this to work, we're going to set up an additional instruction for initializing the token mint, which should only be done once. It will be written such that it can only be called once, and it doesn't particularly matter who calls it. Yeah. Colo. Called only once or something. Where is the L coming from? I have no idea. Given that throughout this lesson we've already hammered home all of the concepts associated with PDAs and CPIs multiple times, we're going to walk through this with less explanation. Start by adding a fourth instruction. Now, the thing is, I would just create the token with CLI to be quick, but I can't do that because I want to create it there at a specific token mint. So the program needs to do that. So I need to write an instruction for it. Just an initialize mint. We don't need any additional parameters for it. So that is now in the instructions. Did we compile? Looks good. No error. Just some warnings because unused imports and stuff, but like we're good. So there we just add the initialize mint, and then we also need in the movie instruction to a third thing. I don't know what though. Self initialize mint. Okay. And then we write that function. Oh, that was just the unpacking. Hold on. Just do this. That's just the unpacking here, and then the matching we do in the processor. Where do we do it here? Yeah, it's already red, and it tells me not all paths covered. So I quick fix this, and then it gives me here initialize mint with a to do, and I replace the to do with initialize mint. That's how you spell it. Not really. Boom. There you go. And then it tells me, well, that doesn't exist. And then I'm like, well, okay, I'm going to create it for me at this function. No, wait, no. What did I do? No, not a function with similar name. I want you to create. Anyway, okay. F this, I'll just copy that and remove the things we don't need. Boom. And then say, okay. There we go. No, still not. Yes. No. What? What's up? Oh, I need to rename that function, obviously. There we go. Okay, cool. Now we're good? Yes, now we're good. Okay, now we just need to implement that, right? Easy. So this function will derive the token mint and mint authority PDAs, create the token mint account, and then initialize the token mint. I'm a bit under time pressure. I would do this myself. Wow, wait. So let's look at that. I replace this with this, remove that to have more space. Gonna turn off the Rust analyzer for more like clarity here. Now, check this out though. You derive the PDAs for token mint and token authority, but then you only ever sign with token mint. Token mint here and token mint here. So here you create the account with 82, which seems to be, I mean, that's a magic number here, which seems to be like the size for token mint, and then you call initialize mint on that same account. So obviously the same seeds. Yeah, I mean, that makes sense. But then and here you provide the mint authority, right? And this, oh, now I turned it off. Damn it. If we have a look at this though, turning the Rust analyzer on again, we say 9 decimals. This is probably the freeze authority. This is the mint authority. This is the token mint, and that's the token program. So token program, mint, mint authority, freeze authority, decimals is what I would expect this initialize mint function to take. Yeah, you know what, I'm quicker if I just Google that. There, token program, mint public key, mint authority, freeze authority, told you, and decimals. Because I'm a pro at token program. I know my shit. Yeah, so that all makes sense. This makes sense, and I don't particularly know why I need the sysva rent thingy here, but apparently that is required. I remind. Also, this one, the 82, I would like to replace with SPL. No, what is it called? Underline token. Rust analyzer, come on. Be ready for me again. Okay, I won't turn you off anymore. I would still like a nice state, and then mint, and then no len. Hehe, there you go. That's what I would import here, which is a U size of 82. Ha, who would have thought? That's the length of a token mint account. So SPL token, what did I say? State, mint, length. There we go. And this, we see, wrong side, there we go, 82. I would prefer to use this than the 82 as a magic number here. It's just nicer to read, James, I'm just saying. But not like it really makes a difference, it doesn't. Except, oh damn it, that's a U64 and I found a U size, damn it. Can I do an into? Does that fix it? Yes! I'm a Rust Pro. No, I'm a noob. Wait, what do you need again? What do I have and what do I need? Expected found. Okay. Yeah, just do this. Yeah, seems to work. It's just an 82. Come on, you'll manage to convert this somehow. Yeah, and we again sign with token mint. We do set the authority to the mint authority. So when we do this here, I would sign as the token authority, James. It's weird that you don't do that. And it would be interesting if it's possible to also set the authority as not the mint authority, but also the token mint. That would be a weird like self-reference, which could like should work really, which I would find pretty sweet. But anyway, but I think like with all of that done now, we're pretty much ready, right? Yeah, and for the 9, I could do a proper constant somewhere and then, yeah, but you know how it would be done properly, right? It's not how I do it, it's how I tell you to do it. Don't do as I do, do as I say. Build and deploy. Now we're ready to build and deploy. Cargo build SPF. Before you start testing, you need to initialize the program's token mint. You can use this script to do that. This script assumes you're deploying to DevNet. So should we also do it on DevNet? Let's quickly do that. I want to get this done. Let's go. So console, build again, ignore warnings. Ain't nobody got time for warnings. It's just one unused imports because I don't want your Lamperts. I don't want to use that, James. I just don't want to use that because we're dealing with tokens, not Sol. So there you go. No more warnings. Ha, he says before it's compiled. There we go, but no warnings. And now we have this target and deploy. There we have it. And this thing that we need to now push to DevNet. Do we do DevNet or do we do localnet? Let's do DevNet. Why not? So we need an account. Damn it. Solana, keygen, the command I use the most. Grind. AND program authority. Wait, starts with, there we go. We have a PEX. Let's go. Solana config set. We use not mainnet but devnet, and we use this key pair, please. And then we say airdrop. Oh, this is gonna take forever now though, because I need to airdrop myself at least 4 Sol to be able to compile to deploy this, I guess. And then I could also put another key pair here, but I don't even want to. Come on, give me a second airdrop. Come on. Never mind, then not. Let's see if it works with 2. Solana program deploy, and then my target deploy and PDA local.so. Boom. Oh, maybe 2 sol is enough to deploy this. Cool. I mean, localnet is faster, yes, but still. Damn it! Yeah, 0x1 told you, just don't have enough sol. And I could go recover that from this account now, but no, I'm just gonna airdrop myself some more. And to make sure I don't run out this time, some more. Again, localnet is much nicer when it comes to airdropping yourself some sol. But hey, it's already very nice on DevNet. Way better than on mainnet. Anyhow, meanwhile, he said this script for calling the program. What does this script do? It initialize program token mint. Yeah, does the same, derives the same addresses, and then creates a transaction with the instruction with all of those keys, including the sysver rand, and then sends and confirms that. Hey, there you have the local host. Okay, so I could have as well done it on local. Anyway, we do it on DevNet such that we have nicer Explorer stuff. Yeah, I mean, let's just clone the entire thing. Why not? There we go. We have enough now. So please deploy again and give me another console where I git clone this thing. Movie token client and PMI. What? Still didn't work? What is happening here? Invalid account data for instruction. What? And another sol lost. Invalid account data for instruction. Now, if you work on mainnet, be careful that you don't show this to people, because then they can recover that 1 sol or recover it yourself first. But like, we're on DevNet and I don't care about that sol. I just leave it here. You can get that 1 DevNet sol if you really want to. So, okay, show me again what's happening here. You're sending out 145 transactions. Invalid account data for instruction. That's all that you say. Strange. Maybe you already started something with this key pair. You know what? Then we say Solana keygen grind, because it's the command that I use the most. Starts with my movie program MP. And can I define an out file like target deploy and PDA local key pair? No out file I can say. Okay, I can't provide an out file, then we don't do that. mpj, and then we just copy, or rather move my mpj from here to target deploy PDA local key pair. There. Key pair changed. And now we try that again. No. We try that again. I hope this works now. Otherwise, I go to localnet and see if it works there. I just want to see it work, man. Invalid account data for instruction. Wait, is my config wrong? Oh, of course it is. Obviously. Okay. It's not so obvious as I just thought. I thought I just have the wrong key pair. But we're not in Anchor, so I don't provide the key pair as the public key. I don't need to write anywhere my public key, do I? I don't. In Anchor I do declare, but like here I don't. I don't get it. You know what? Let's do it on local. Let's see if that works. So yet another thing, and be like Solana test validator. There we go. And then we Solana config set to local. Solana airdrop 1,000 or 100, who cares? Oh, we're not ready yet because we're still initializing. Okay. There we go. We're running. Oh, that's a nice slot, yo. Cool. So give me some. Perfect. Much nicer on local, I tell you. And then we do the deploy thing again. Ha, much quicker as well. There we go. Easy. Boom. We have the program mpj deployed. And we now just need to pass that into our movie. There we go, into that index.ts. And we just execute that. That should run. It's on localhost as well. Yeah, let's just run this. So we would do ts node index, source index. No. So essentially that just calls this instruction that we just wrote with the initialized token mint. So it should have a 3 somewhere. Yeah, the buffer of 3, that's the data, that's the instruction that we call the fourth instruction. There we go. And we're not on definite though, but we will just Solana confirm with -v and check this out real quick. Then we will see nice slot still. Those are the accounts, and let's just read the log. So our program was called, this will be the token mint and this will be the authority. So drag will be the authority, drag. And then the system program was invoked to create the account. And then the token program was invoked. And here we can see the depth, I think. So that's depth 1 and that's depth 2. So maybe it is limited to depth 4 and then we cannot do a fifth one. Damn it. Okay, but whatever. And here the initialize mint from the token program is called, which comes back with success, and then we also return success. Sweet. Which means that this token mint should now exist, which again, if we were to do that on DevNet, we could look at that nicely, but like on local, I think this doesn't work so easily. Custom RPC URL. Yeah, that. Can I check that? No, because it's just, that just stays loading. Okay, never mind. And then the mint authority is this. Now the token exists. So token mint should exist now. Solana account, this one. Yeah, there we go. Length 82 bytes. Owner is the token program. And you know, we could calculate somewhere here stands the mint authority. I think that might be the type. Somewhere here is the mint authority. I could decode it, but like I'm too lazy. So let's see if we can get our front end to work and get us some tokens. Gonna airdrop them some sol. And now let's use the movie review front end to test this. The movie review front end, 9 branches, solution add tokens. I think that's the one we need. I'm gonna assume that's the one we need. Right after it's done installing all the packages. Damn it. Give me another console. Check out this, yo. Check. What the hell is going on here? What if I just start npm run dev? Okay, so I have to start this from Windows. Okay, last thing. Okay, git stash git. Check out this branch. There we go. So, good. Round branch solution add tokens. Let's npm I one more time here. Uh-oh. No! Is that the same thing? This is always annoying if you have dependency issues. But they're all with higher, right? Can I just... Wait, can I just add this? And this, wait, this, just use higher versions if you can't find them. I don't care. Just install whatever. I'm gonna fix the issues if you can't like compile later. First install anything and hope that nothing changes, which is just not gonna be the case. Uh-oh. No. Is it the same error that I had here? Yeah. Oh, let's just try it with force. Not what I usually recommend in life, but maybe for npm packages that's alright. Just force a new version on it. Who cares about dependencies? It doesn't like to be forced, does it? But it just continues this time. This will cause problems along the way, I tell you. Run, dev, run! Alright, I mean, that's looking good. Let's see. Does it compile? Oh no, error. Endpoint is defined multiple times. Oh, that's interesting. It doesn't even compile out of the box here. Wow, but that looks like an error that I can fix. That's true, it is defined multiple times. And I want localnet, so we're just gonna remove this. And this is red, so I don't know what that means, but we'll leave it. Wait, compiling. We'll then also have to change the movie. Where did I do that? Oh no, something else. Was no module graph assigned to module for backward compatibility. Oh no. See, I knew it would cause errors. But then it says compiled client server successfully, so maybe just a little bit of front-end stuff that doesn't work. Let's see. How do you look? Well, but that's the previous issue. Yeah, yeah. Oh, that's looking better. There we go. That's what I want to see. But before we can do anything useful with this, we need to change the program ID. I don't remember where I did that. I think in the form. Movie review program ID. Where are you? There. There's one constant in constants. Perfect. Love it. So you shall be changed to address of my target. Oh, here I'm in the front end. Target, deploy, and then the key pair. This thing goes here. Let's go. And then it's compiling again. There we go. And then we refresh this one more time. Oh, what did I do? So we created the token. The only thing that we still need to test is whether we manage to get the tokens if we leave a review. So my wallet has 2 sol. Let's add a review. First connect the wallet. See if that works. Connecting. Yes. So good. I can't handle it. 5,000. Okay, 5. And submit. And this is always the tough part. Will it simulate or will it not? Yes! Yes! Did you see that was already the token? I mean, it was 9 tokens and I thought I would get 10. So my decimal game is still... Oh! I know why. I know why. But it works. It works. I get tokens. I get tokens. I have 0 tokens, but I have like 0.0000000. Fuck, 0.00009. Give me 1 second. A classic. Okay, yeah. That's totally on me. That's totally on me. Where did I do that? In processor with my decimals. Where do I have my decimals? There. I have 9 decimals and then I multiply with decimals, which of course is just this. Okay, I have 10 times 9. So that, of course, this thing is supposed to go to the power of 10, which I completely forgot. Oh man, that's stupid, but also kind of funny. So let's compile this thing again. There, and then redeploy, and then we do this again. Oh, how does that work in Rust? Times pow, and I want U64 pow, U64 pow of decimals to the power of 10. Yes, that's what I forgot. Okay, rebuild this. We're not in TypeScript. We gotta learn Rust, yo. It's so nice and fast on local net. Yes, and now if we do the same thing again and submit another video, submit, then look at these. We see here, what? 34.8? I mean, I take it, but I would have expected that to be 10. Damn it. What's not working now? But hey, like, I mean, it works. It works. It just doesn't work correctly. I now have 34 tokens. Let's have a look at such a transaction. You will not find that because we're on localnet. Can I set you to localnet? RPC is unavailable. Oh, shit. Okay. Well, let's have a look down here then. Solana confirm -v. Boom. So what happened here is another video, and then invoking the system program for create, okay, and then invoking the system program again. And here we invoke the token program with a mint2, and that also has success. But hey, here it says minting 10 tokens to, well, okay, that's just my debug message. Okay, never mind, that's not the token program. So apparently I still give the wrong value in there. Can I see it again? What am I doing? So amount equals 10 times U64 power decimals exponent. Wait, did I get it wrong? I did 9 to the power of 10 instead of 10 to the power of 9. I'm so stupid. Sorry, that's my bad. I want 10 to the power of... It's too late already. I'm just confused. Decimals, of course. Because the more decimals, the more zeros. So the 10 another time, another time, another time. So 10 times 10 times 10 times 10. So to the power of decimals. Damn, just the wrong way around. So, okay. Yeah, well. So let's build that again. And then, now it then hopefully gives me the right value. They're fixing this. Deploy this again. So now, but it was already in the right ballpark. Let's just do it one more time. Submit another thing. Oh, this will not work because it's the same movie. Yes. So never mind. So make it yet another video, and then we will get plus 10. Yes! Now it works correctly as well. Approve. We get 10 more tokens. Point of all this being our program can mint us some tokens. And the fact that it works tells me that I did it correctly. And I provided the token authority here. Because James in his code, if we check that again, he ignores this and just takes the token mint. And then also here he provides, for minting 10 tokens, he provides the token mint. If I were to do it like him, if I were to provide his seeds like that, and I compile this, then I'm pretty sure that that's not gonna work. Now we deploy this. Now what do I expect actually as the error? I expect a token program to be called, and then I expect the token program to give me an error saying something like unauthorized, owner incorrect, or something like that. So let's try this. Not working. Let's see. Fails to simulate transaction. Yes. And if I still approve it, the error will be signer privilege escalated. Can I have that? Wait, can I have that in a proper console? Yeah, it's a lot of red, but who cares? So, comment counter there, minting 10 tokens to user associated account. That guy, signer privilege escalated. Because we expect a signature for this guy, but don't provide it. So we have a signer privilege escalated. So it didn't even make it all the way to the token program. My prediction was wrong because it already before checked. Because here, that mint instruction, that creates an instruction that has the account matters where the mint authority is a signer. And then I don't sign for the mint authority though. I sign for the token mint, which is completely useless. So James, I'm gonna make you a pull request where we fix that. And then you can be like, you're wrong. Or I'll be like, and maybe I am. Maybe I don't understand what you're doing, but I think that I'm right. Pat myself on the shoulder, finding an error, and then we move on with our lives. But it got me thinking, when we, this seems cool, providing the token mint like this, just then we also need to use the token mint as the authority. And for a normal token, this doesn't make any sense, right? For if I do that on the CLI, I can't make the token itself also the authority. Although, actually I could if I hold the key pair, but then I cannot sign for it anymore. Let's try, hold on. Let's do that. Yes, I'm rabbit holes. So if I were to... Token. Oh, there we go. Toss is my token. And then I SPL token create token with that TOS. So we have that token now with 9 decimals. Oh, damn it. I effed it up. Try that again. One more time. We grind ourselves a token key pair. There. To3. Then we create a token. SBR token create token. But we don't set ourselves as the mint authority. We set, let's see, how do I do that? Fee pair URL, mint authority. We set the mint authority to an address. So we set the mint authority to this address, and then we also use this as the key pair. Cool, sounds good. SBR token create account of this token, and now can I SBR token mint 10 of this token? No, always get it the wrong way around. No, because why not failed owner does not match, so the authority is not correct. But can I do, wait, give me some help here. Can I provide a separate authority, mint authority here, and then I provide the key pair? So we do mint authority, and then I provide the key pair, the token. Then I can suddenly mint some. So that actually works. I can have the token itself as the mint authority, which is at the same time genius and also stupid, but I kind of like it. I mean, in that case, it doesn't really make much sense, but for the program it does. Why? Because we save another account. I don't need to pass in the mint authority here in all the account info, so I can leave that part out, which keeps my transaction size small, and the transaction size is often a bottleneck. So this would actually be super cool if we could leave that out. And if we were to do something like James already wrongly did down here with providing the token mint as the seed, we can do that, but then we just need to create the token a different way. Should I just redeploy the program to a different program? Now cut out all of this. I'm just gonna change the program ID, new program, and then I move over the new program to target. Now I don't need the old program anymore anyway. We're just on localnet, right? I can do this. Deploy key pair. Oops, I overwrote the other key. I need to do this because I need to create the token anew. So this is my new program ID now. I shall put that here as well. And in the index. So here when we do the initial token mint, first in the program where we initialize token mint here, there, where we provide, oh no, this is just a create account, there, where we provide a token program ID and the mint authority. I can now also provide the token mint as the mint authority here, and then assign with a token mint. Let's save this and compile this and deploy this now to a new address. There, new address. Now in the index, I don't actually need to change anything because I can derive both of them. It's fine. I'll just have to also execute that one more time. How do I search recursively? There. Oops, did I do that here? Where am I here? Movie token client. Yeah, there we go. We have to do this to create the token. Good, still here. Is it coming through or not? Yes, finished successfully. So the token was created, and let's actually look at this. Oh, come on. We see token mint and mint authority, but the mint authority we don't really care about. Token mint is now a different one because different program ID. 5WN is now my token mint, and also the mint authority is now this one, which is a funny setup. I like it. now still having those seeds here, the token mint seed for the minting, because this is so funny. This PDA is now the token ID, so the token mint, and at the same time also the mint authority, and I as the program can still sign for it because it's still my PDA. This is so cool. Let's see if that actually works. If we submit another review here, this should now be working. Oh no, it does not. Oi, oi, oi. Oh no, what's not working now? Signer privilege escalated again. Uh-oh. Oh, well, of course. I now also need to provide it correctly here. I provide not the mint authority, but the mint PDA. Also need to do that, of course. And then we do that whole thing one more time. Oh, no, not this. This. But now working. Let's see. Come on, you can do this. I want 5. I want 10, 5, some. Oh, what's the error? Oh, man. Still signer privilege escalated. Wait, for a BKR? That's a complete... Oh, wait. You made it in here. But then you still have the wrong address like before. Was it not? Maybe the program wasn't ready yet. Maybe let's just refresh here. Maybe I didn't wait long enough. Give me tokens. Ah, come on. Okay. But now, give me tokens. Come on. You can do it. You can do it. I want 10 of those 5W. No! Why not? What's your problem? Program. Still expecting this. BKR. BKRL. But that's not my token mint. Oh, man. I mean, I don't have to change anything in the front end because I just don't use the account that the front end provides. I just ignore it. Check the mint instruction again. Mint2 with the token program ID, the mint PDA, user ATA, and mint PDA again. Ah, it's so obvious. It's so obvious though. It's so obvious. Look here. It's right here in front of me. Of course, if I provide the signer pub keys here. So the signer pub key is then also the mint PDA and not the mint authority PDA. Obviously. Okay. That's why you're checking for this. Right. That makes sense. Cool. But that should now fix it. Look at that. And we deploy again. But now, when we now go here and say, gimme tokens, then, come on. We get 10 of those 5 yes! We get 10 of those 5 WN tokens. Yeah. Nice. Oh yeah. I like it. Check this out. I love the tokens. And it's so cool to have the token mint as the token authority as well, as the mint authority. This is such a cool concept. I haven't thought of this before, and I'm so amazed by it. I love it. I just fucking love it. All right. Cool stuff. So your challenge is to do the same thing with the student intro program, right? Yes, it is. But that concludes part 3 of module 4. We are done with this. Nice. Now, I hope that you learned something about CPIs or Solana in general today. Let me know that you like these videos by hitting that like button and subscribe for more Solana development content. And then I see you in the next video. You can also check out these and follow me on Twitter and tell me I'm doing a good job because I need it. This is my job now. This is literally my job now. Amazing. The way life goes.